Hello everyone, and welcome to my channel. This is an educational channel, and we try to shed light on some great theories of everything and um, magnum opuses from obscure geniuses and ancient philosophies explicated, and anything else that I think you could really benefit from if you knew about it, but you probably don't because it's been suppressed. And today is our 363rd video on Dewey B. Larson and his reciprocal system of theory. Mr. Larson lived in the 20th century, born in 1898 and died in 1990. Around 1930, while working as a mining engineer out in Portland, he had some great epiphanies while trying to solve a somewhat related problem, and he worked out his thoughts over the course of the next 25 years, 30 years, and in 1959 he put out his two fundamental postulates about the nature of this universe, and then took those postulates, turned around, and through a process of deduction created a theoretical universe, how the universe would look if his postulates were correct. And it just so happens that his theoretical universe compared very favorably to the universe that the scientists had worked out over the thousands of years through their observations, measurements, and hypotheses, and experiments. Except that it disagreed with a lot of the 20th century findings. And it disagreed with the Newtonian universe in the extreme realms that the 20th century findings were there to, to correct. So it really accepted Newtonian mechanics to the same level that we do today, but then kind of trying to fix the Newtonian mechanics in the realm of the very small, the very large, and the very fast. It rejected those corrections that were done by Einstein and the quantum mechanists and other people, string theorists, and so on. Now, the basic idea behind Larson's postulates, Larson's first postulate is that the universe is made entirely of one component, and that is motion. Other people have had that inkling before. Thomas Hobbes and Rene Descartes, to name two giants, but they were not able to build a theoretical universe in the way that Larson was able to do, because they didn't redefine motion in the way that Larson did. The first thing that Larson does is he defines motion as the relationship between space and time. What he says in his postulate is motion has two reciprocal aspects, space and time. So from that, you can gather that basically motion is a fraction with time or space as the numerator, space or time as the denominator. For example, speed. Speed is space over time. The bicycle is moving at 10 miles an hour. 10 miles of space and 1 hour of time. And you can also see the reciprocal relationship between space and time in that. If you decide to double the speed, you can say the bicycle is now going 20 miles per hour. Or you could say that the bicycle is now moving 10 miles per half hour. They're both the same, but in one you multiplied the space by 2, and in the other one you divided the time by 2. That's a reciprocal relationship. Also, space and time have no independent existence. They only exist together in motion. Like all reciprocals, space and time multiply to get 1. And they both have the same qualities to them. One of those qualities is their clock aspect. Larson calls this clock time and clock space. And I think if I were critiquing Larson's postulates, I would say that I feel like he should have used one more adjective to define motion. The universe is made out of one component, motion. I would have put progressing motion or scalar motion, or maybe even non-local motion, to delineate it from just the general vectorial motion that we generally think of as scientists or people that are interested in science, scientophiles or whatever, that this kind of motion that Larson is talking about is not really the same as vectorial motion. It's what is called scalar motion. It's a motion that has a magnitude, but it has no specific direction. A vectorial motion is like 10 miles per hour south. Vectorial motion has a direction. A scalar motion has no direction. You can see this by using your expanding balloon with dots on it. As you blow up the balloon, all of the dots are moving away from each other, but they're not moving in any specific direction. In fact, it's not even just the dots. All the other locations on the balloon are also moving away from each other, and not in any specific direction. This is a scalar motion. It's a motion that has a magnitude but has no direction. And the only way that it acquires any type of direction is if you arbitrarily decide that one of the points, one of the locations, is motionless. When you decide that one point is motionless, then you can start reckoning the directions involved of all the other points in reference to this so-called stationary point. And so that is what Larson calls clock space. The space is always getting farther and farther and farther and farther apart. Clock time is that things are always getting later and later and later and later. So the clock is already demonstrating a scalar motion. It is a motion that has a magnitude, but the clock has no specific direction. It's just getting later and later and later. So this is a motion that is observable in reality, but it's not given any type of emphasis or investigation by the mainstream scientists, They look at it as kind of like an anomaly, even though they also, through their telescopes, have discovered that all of the distant galaxies are moving away from each other. So, they should have been investigating scalar motion, but they have not. Larson, on the other hand, puts it at the center of his theory, the universe, center of the universe. This is what the universe is constructed out of, scalar motion. And he says that the motion is in 3 dimensions. And this is, again, from just the whole concept of reciprocity. He observes that space has 3 dimensions, calls that coordinate space, 3 dimensions of space, volume, XYZ coordinates. And that's something that we almost take for granted. Some of us might go into higher dimensions than that as well, but certainly these 3 dimensions of space. But then he also has something that's called coordinate time, 3 dimensions of time. And that's because space and time are reciprocals of one another. And so if space has 3 dimensions, then we can just assume that time also has 3 dimensions as its reciprocal. Because reciprocals have the same qualities. Just like, the quantities 3 and 1/3. 3 over 1 and 1 over 3 are reciprocals of each other. They multiply to equal 1, and they both have the same qualities. They have 3 and they have 1, but they have them in different orders. And then the last major part of his first postulate is that space and time both come only in discrete units. There's a minimum unit of space and a minimum unit of time. You have to have a full unit before either one of those things is operative. You have to have a full unit of space or a full unit of time, or really a full unit of motion. Motion, again, being a fraction, with space or time as the numerator, time or space as the denominator. All of our basic scientific quantities are expressible exclusively through space and time. You don't need mass. You don't need this MKS system. Just use space and time. Motion is space over time. Energy is time over space. Acceleration is space over time to the 2nd power. Force is time over space to the 2nd power. And it goes on and on like that. Mass is time to the 3rd power over space to the 3rd power. Pressure is time over space to the 4th power. And, momentum is space to the 2nd power over time to the 2nd power. All of these different things are expressible specifically and exclusively in terms of space and time. And if you have 1 unit of space in 1 unit of time, space over time being speed, if you have 1 over 1, you have the speed of light. And this is 1 unit speed. 1 over 1 equals 1. So this 1 is where all of your reciprocals resolve each other. This is like multiplying your 3 and your 1/3 to get 1. 1 is at the center of a reciprocal system. Just like 0 is at the center of a legacy science system. You have 0, and then in the positive direction, you have 1, 2, 3, 4, 5. In the negative direction, you have -1, -2, -3, -4, -5. In a reciprocal system, you have 1 at the center, and then on one side, you have 2, 3, 4, and 5. On the negative side, you have 1/2, 1/3, 1/4, and 1/5. So that is how a reciprocal system works. And in a universe of motion, it makes complete sense that your 0 point, your origin, your center point, your neutral point, your null point, your state of rest, is motion. Motion outward at the speed of light in all directions. So just to read, not read, because I'm not reading it, but paraphrasing Larson's first postulate again, the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. And then his second postulate is that the universe conforms to the rules of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Now, some of Larson's followers and eventual revisers have rejected parts or all of that second postulate, especially Dr. Bruce Peret, who I believe, in my opinion, is one of the 2 greatest, revisers of Larson's system. Now, there are some people who go after Peret and believe that Larson, they're orthodox, and they believe that Larson didn't get anything wrong, and that, it's foolish to even question it, almost. But I believe that Dr. Peret made great revisions of Larson's system. And Larson himself did say that he was subject to error. The system itself, he believed, was correct, but whether he derived everything from that system was another question. And Dr. Peret disagreed with the geometry of the universe. He believed that the geometry of the universe was projective, not Euclidean. And there were a few other things involved. But today we're actually looking at a paper written by Bruce Peret called RS2-109. RS2 being the reciprocal system 2. This is the re-evaluation of the reciprocal system in light of new findings and so on that Dr. Peret, along with Dr. KVK Nehru, did in the early 21st century, and maybe late 20th and early 21st century. Dr. Peret died back in 2020. I do believe that Dr. Nehru is still alive, living over in India. And this paper is called Dimensional Thinking. And I believe it was written by Peret back in 2015. He starts with a quote from the movie Contact. Contact. An alien intelligence is going to be more advanced, and that means efficiency functioning on multiple levels and in multiple dimensions. Okay, this is the start here. Human perception is based primarily on 1- and 2-dimensional thinking. For example, all locations in space can be connected by a 1-dimensional line, regardless of how many twists and turns it takes to get from start to end. Eye focus. Our vision works like a 2-dimensional projection screen with a lens focusing an image on the surface of the retina. With 2 eyes, the mind can give the illusion of 3 dimensions by focusing on a distant point to create a triangular relationship and estimate the distance to that point. But we don't actually see in 3 dimensions. We internally recreate a 3-dimensional geometry from 1- and 2-dimensional information. If we had senses that perceived 3 dimensions, one would be able to see the back of an object as clearly as the front. So we create this three-dimensional thinking from our stereoscopic vision, the triangulating two different images that we're getting in each eye, and then from each eye, and then we're able to kind of make it appear as if we have three-dimensional vision. The mobility of thought has carried over into everything we do with our senses, including the inductive theories created by observation. Dewey Larson created his reciprocal system through induction, observing that the atoms of the periodic table could be accurately expressed by three magnitudes rather than a one-dimensional atomic number. If those magnitudes were the inverse of spatial magnitudes. From this pattern, he hypothesized that this inverse magnitude must be time, as mechanically described by the concept of speed, the inverse relation of space to time. But that also inferred that time, like space, had three dimensions, and both space and time were related to each other as aspects of motion. From this, he developed his theory of a universe of motion, now known as the reciprocal system of physical theory. Now, this to me shows how kind of different Dr. Peret and I think, because he can go over this over and over again. It doesn't register with me, just the way that he explains. I hope it does for you. I hope that this clicks for you, because it doesn't click for me. I've read this passage many times and I don't get anything out of it. Maybe someday it will click, but I just don't really think that way. But this is what Larson was doing. Larson was originally working on a problem having to do with the interatomic distance of different elements, and he had the epiphany that why don't you just assume that time is the reciprocal of space, and then you substitute it in your periodic table, and that's basically what he did. And he ended up kind of deriving a different periodic table where each one of his elements requires three numbers to properly specify it. There's a primary two-dimensional rotation, a secondary two-dimensional rotation, and a one-dimensional rotation that can be positive or negative. And so that is the process that Larson went through, but I just don't, that's not the way that I think of it. Okay. From this inductive theory, Larson created two postulates to define his conceptual basis, then proceeded to deduce the structure of the physical universe. From those postulates, to see how close it matched the original observation. Okay, so he's basically just explaining how Larson started with this inductive process and then created his two postulates and then switched over to a deductive process. And then through his deductive process arrived at a theoretical universe that he then compared with what the scientists had already come up with. Larson, however, was still caught in the paradigm of one-dimensional linear thinking. This is evidenced by the fact that he could have linear motion without anything moving, but could not have angular motion without something to rotate. Angular motion being rotation. In his case, the photon provided the stick to spin into the concept of the rotational base. One dimension spinning to make two. Yet he also postulates that the universe is three-dimensional in nature. In his paper, The Law of Conservation of Direction, Professor K.V.K. Nehru states, quote, rotation is precluded only if space is one-dimensional. Just as soon as it is established that the stationary spatial reference system is three-dimensional, rotation becomes a possibility and introduces the concept of rotation being primary, meaning that the angular velocity behind rotation is just as likely as the translational velocity of Larson's directional reversal. Rotation without anything to rotate. So Peret is here just kind of going over Larson's formation of matter. How does matter come about? And kind of critiquing that process. In Larson's universe of motion, there's really four kinds of motion. You have your translational motion. You have your vibrational motion. You have your rotational motion. And you have your rotational vibration. And these motions can be in multiple dimensions, depending on the situation. And Larson basically said that you cannot have rotation unless you have something to rotate. So he first had to postulate this photon, which is the thing that is to rotate. And the photon is based on both a translational motion and a vibrational motion that is 90 degrees offset from the translational motion. So the vibrational motion is going in this direction, and the translational motion goes like this. When you combine the two of them, you get a sine wave. And Nehru eventually came along, and he posited the photon as a birotation, not from a vibration and a translation, but from two counter-rotating systems. And when you have two counter-rotating systems, according to the 18th century mathematician Euler, he says that that creates a cosine wave. And so that also creates a photon, potentially. So that's kind of what this dispute here is about. What is the nature of the photon? And, you know, for Peret, the vibration doesn't come about until you have two separate motions. And that's what creates the photon and also a vibration. But the photon, both the rotation and the translation are equally primary. He refers to one as yin and one as yang. Spin is yin and translation is yang. And he accuses Larson of being yang-centric and ignoring the yin half of his universe. Okay, now we will we'll start up again tomorrow in the middle of this article and hash it out a little bit further. It's not an easy article, but hopefully we set the stage there, and hopefully you'll tune in tomorrow and we'll check out. I don't know if we'll get all the way through this paper, but the next installment will be tomorrow. So thanks for tuning in today. Have a great day.